In this programming example, I will show you how to use pre-trained embeddings. I will use embeddings known as GLO. Before diving into the programming example, let's just discuss a little bit about similarity metric for word vectors. So in this figure, we see three word vectors, A, B, and C. And we see that these are not normalized in that they have different length, as you can see. We see that the distance between A and B, this distance, is less than the distance between B and C. One very intuitive metric when looking at the distance between vectors to use the Euclidean distance. However, there are also other distance metrics. We can use the cosine distance. For example, it looks at the angle between the vectors, and we can see that the angle between A and B is greater than the angle between B and C. So according to cosine distance, B is closer to C than A is to B. That raises the question, what metric to use? And there is no clear answer. Sometimes Euclidean distance works better, sometimes cosine distance works better. However, it's also worth noting that if we work with normalized vectors, both metrics will leave the same. That is, we see that both for Euclidean distance and cosine distance, B and C are closer to each other when we are working with normalized vectors, as you can see. In this Google Colab notebook, we will look at how we can read some pre-trained GLOV embeddings and how we can use them and do some word vector arithmetic on them. So what we will do here is simply read these embeddings from a file. You can find this file either in Kaggle or on my Git repo in the description of the video. So the file for each line there will contain the word and then the corresponding numbers for that embedding. So we will read for each line and we will split the line into getting the word itself, which is the first entry on that line, and then we will create an array containing all numbers corresponding to that. So we will have embeddings dictionary, which have the embedding, so we can index that by a word, and from that we will get the corresponding vector. So we have defined that function that will read the file. But we need a function that can find the closest match. We want to look at what embeddings are close to other embeddings. So this method will take the full dictionary of the embeddings and a specific vector and a number n. And then it will go through all of the embeddings and we will calculate the distance between those embeddings. We will use the cosine similarity matrix here. So this function will simply print out the n closest embeddings. Here, we will first read the embeddings, and then we will look up the embedding for hello, and we will print the n closest words to that, and then we'll do the same thing with precisely, and the same with dog. So we can see here that we have 400,000 embeddings that we have in the file. So we read all of those, and then the words that are closest to hello is hello itself. As you can see, the distance is 0, which means that it is the closest word. So this is a word with itself. And then we have goodbye and hay. These are the distance. So these embeddings clearly have grouped words so that similar words are close together. For example, for dog, dog itself, the distance is 0 between them. And this cat, this is the distance between dog and cat. And here, dogs with dog. Let's now look at if we try to do vector arithmetic on these word vectors. We are going to take the word king and print the n closest embeddings to the word king. And then we will take the vector king and subtract man and add woman. Then take that resulting embedding and we will see which words that are the closest to that. We can see that the closest word to king is the king itself and prince and queen. However, when we subtract the male component from king and add woman, that queen now is closer to king than monarch. So this actually shows that we are now getting closer to queen than we were to prince. And that's how we can use word vector arithmetic to see these kinds of relationships between words. Another example is using cities and countries. We have the country Kuwait, and we see what the words are closest to that. And we will take the city of Doha, which is the capital of Qatar. I subtract Qatar from Doha and add Kuwait component. We can see that the words are closest toward Kuwait is Bahrain and Qatar. Those are the neighboring countries for Kuwait. And when we remove Qatar from Doha and Kuwait, we end up with Iraq as a result here, which is the closest country to Kuwait.